speed of sound in air is 332 meters per second. The frequency of the fundamental note of an open pipe 50 centimeters long will be. There is an open pipe. Then we can draw fundamental frequency should be like this. You know that open ends should be anti-notes and there is only one loop, half loop and half loop. Then length of one loop is wavelength, half of wavelength, lambda divided by 2. And it is equal to the length of the tube. Then we can write lambda over 2 equals length. Now we can subject lambda 2 times length. Length of the tube is 50 centimeters. Therefore, 2 times 50 centimeters, 100 centimeters. We can get wavelength is 1 meter. Now we can use V equals F lambda to find the frequency. V equals F lambda. V is the velocity of sound in air, 332. We have to find the frequency. For the fundamental frequency is F naught, lambda is 1. Then we can find F naught value. F naught is 332 Hertz. Then answer is 4. Which of the following will produce overtones with even integral multiples of its fundamental frequency? We know that when considering an open organ pipe, it means it should be like this. We can observe F naught, 2F naught, 3F naught, all overtones. Therefore, we can produce even overtones by using an open pipe. Then we can consider A is correct. Then B, an organ pipe closed at one end. For a closed tube, we can observe fundamental, first overtone, second overtone, like this. This is the fundamental frequency. We can get it as lambda over 4, 1/4 of wavelength. In this one, there are 3 parts like this. Therefore, 3/4 of wavelength, length of the tube. For this one, 5/4 wavelength. Therefore, we can observe only odd overtones for the closed pipe. Therefore, B is incorrect. We can't get even overtones by using a closed pipe. But part C, a rod clamped at the center and producing transverse vibration. When considering a rod which is clamped at the midpoint, we can get only one resonance like this. We can consider this one is the first fundamental, but we can't get overtones for a rod. Therefore, only A is correct. There is no an answer for the question. Therefore, they have given all marks. You have to remember that. We can get only fundamental frequency for the rod. If the rod is clamped at one end like this, we can get only one vibration pattern like this. This is the fundamental of the rod when clamped at the midpoint. This is the fundamental when clamped at the end of the rod. Two pipes and two pipes, one closed at one end and other open at both ends, have length L1 and L2 respectively. If the two pipes, when sounded together, have the same frequency at their first overtones, L1 over L2 is equal to. Now we have to consider first overtone. For the first pipe, it is a closed one. We can get first overtone like this. Then length of the tube equals to lambda over 4 times 3. We know that 1/4 of wavelength is half of loop. There are 3 half of loops. Therefore, 1/4 of wavelength times 3. Lambda over 4 times 3. Then we can write L1 equals lambda over 4 times 3. Lambda equals 4L1 over 3. We can use V equals S lambda for this tube. V is velocity of sound in air. It is not changing with tube type. It is constant. They have given that there is the same frequency. We can get F as the frequency. Wavelength is 4L1 over 3. Now I will consider open tube. Length of the open tube is given as L2. And we have to consider the first overtone. We can draw the first overtone for the open tube. And there are 1, 2, 3, 4 half of loops. Then L2 should be equal to lambda over 4 times 1, 2, 3, 4. Lambda over 4 times 4. Then we can write lambda equals L2. We can cancel out 4 and 4. And we can use V equals F lambda again. V equals frequency is same as previous one. Therefore, we can consider frequency F. Lambda is L2. Second equation. Now there are two equations. Left hand sides are same. Therefore, we can equal first equation and second equation. For F into 4L1 over 3 should be equal to F into L2. Now we have to find the L1 over L2 ratio. We can cancel out F and subject L1 over L2 ratio. It should be 3 over 4. Then answer is 4. Consider the following statements made about vibrating air columns inside the tube closed at one end. Statement A. The frequency of the first overtone is twice that of the fundamental. So we know that for a closed tube, we can observe F0, 3F0, 5F0, only odd overtones, odd harmony. Then part B, the maximum air pressure occurs at closed end of the tube. Yes, it is correct. We know that at the closed end, pressure should be maximum, displacement should be minimum. Displacement should be 0. Then see, the wavelength of air column change with humidity. Yes, it's also correct. We know that with change in humidity, velocity of sound is changing. V is changing. Therefore, wavelength should be changed with humidity. Then C is correct. B and C are true. Then answer is 4. Consider the following statements made about stationary waves produced in a pipe open at both ends. A. Allowed oscillation modes from pressure nodes at each of the ends. Yes, it is correct. Consider the following statements made about stationary waves produced in a pipe open at both ends. A. Allowed oscillation modes from pressure nodes at each of the ends. We know that for an open tube, displacement is maximum for the both ends. When displacement is maximum, pressure is minimum. Therefore, we can consider it as a pressure node. Displacement maximum, pressure minimum. Therefore, we can observe pressure nodes at both ends. Nodes means there is a minimum value. Pressure nodes, but displacement antinodes. Then A is correct. Then statement B. Allowed frequencies consist of all harmonies of fundamentals. Yes, we can observe F0, 2F0, 3F0, all harmonies for open tube. Then C. The length of the pipe corresponding to allowed oscillation mode is always an integral multiple of wavelength. No, we can't get it as integral multiple. B is correct, C is incorrect. We can't observe integral multiples of wavelength. We know that we can observe lambda over 4 times 1, lambda over 4 times, lambda over 2 times. There is an open tube. Therefore, lambda over 2 times 1, lambda over 2 times 2. When considering lambda over 2 times 3, we know that it is 3 over 2 of wavelength. Therefore, it is not an integral value. We can't get integral values always for the open tube. Then only A and B are true. Answer is 3. An organ pipe of length 50 centimeters is closed at one end. If the speed of sound in air 300 meters per second, the two lowest resonance frequencies produced when pipe is sounded down. We can observe lowest frequency for the fundamental note. Then it is an organ pipe closed at one end. We can consider lambda over 4 equals length of the tube. It is the fundamental note. Then we can get lambda over 4 equals L, lambda equals 4L. Then we can use V equals F lambda. V is 300. It is given in the question. We have to find the fundamental frequency F0. Wavelength is 4 times L, length of the tube. 300 equals F0 into 4 times. Length of the tube is 50 centimeters. It means 0.5 meters. 4 into 0.52, 300 divided by 2, 150. Hertz. It is the fundamental. And we know that when considering a closed tube, we can observe first overtone 3 times of fundamental. Then 3 times 150, 450 Hertz. Then minimum frequencies for we can observe 150 Hertz and 450 Hertz. Then answer is 2. The fundamental frequency is not produced by a certain closed and open tubes are same. The open pipe is inserted fully into the closed pipe until it hits the bottom of the closed pipe. If the incorrections are neglected, the corresponding fundamental frequency of new setup will be. There are 2 pipes, open and closed. We know that the fundamental frequency of open tube should be like this, fundamental wave pattern. Then there is one loop. One loop means lambda over 2, half of wavelength. It should be equal to the length of the tube. I will consider it as L1, length of the tube. Now we can get lambda over 2 equals L1, lambda equals 2L1. For this one, fundamental should be like this. Lambda over 4 equals L. I will consider it as L2. Then we can write lambda over 4 equals L2. Lambda equals 4L2. We know that velocity of sound is not changing with tube type. Therefore, V constant. They have given that there is a same frequency, F constant. If V and F are constant, we know that lambda, wavelength also constant. All 3 physical quantities should be constant for both tubes. Then we can get this wavelength equals this one. 2 times L1 equals 4 times L2. Then we can cancel out. L1 equals 2L2. Then long tube is this one. Short one is this one. Now they have given open pipe is inserted fully into the closed pipe. Now it is like this. Closed pipe and open pipe. Open pipe is fully immersed to the closed pipe. Then this length should be L1. It is the long one. This length should be L1. And when considering fundamental, the wave pattern should be like this. Then L1 equals lambda over 4. Now lambda is 4 times L1. We can compare wavelength. When considering this situation, wavelength is 2 times L1. Now wavelength I will consider it as lambda dash. Lambda dash is 4 times L1. It means wavelength should be twice of previous one. According to V equals F lambda, if V constant, V is always constant for this problem because of it is speed of sound in air. Then frequency inversely proportional to wavelength. When the wavelength is twice, frequency should be half of initial value. Then we can get F0 over 2 is the new frequency. Answer is 2. For the when 2 organ pipes, length 50 centimeters and 50.5 centimeters are sounded together, 3 beats per second are heard. If the incorrections are neglected, the frequencies of pipes are respective. We can observe 3 beats per second. 3 beats per second. Beats frequency means difference between frequencies. And we know that when the length increases, frequency decreases. We can consider a relationship like this. Velocity of sound constant. When length increases, frequency decreases. Therefore, we can observe high frequency for the short tube. It means 50 centimeters tube. We can get for the fundamental frequency, they have not given the tube type. Therefore, we can consider it is closed one or closed 2 tubes or open 2 tubes for the problem. Then I will consider closed tubes. You can solve the problem by using closed tubes and open tubes separately, and you can understand there is the same answer for both types. When considering closed tube, fundamental of the closed tube, lambda over 4 equals L, lambda equals 4L. We can use V equals F lambda. For the short tube, frequency is equals to velocity divided by wavelength. V divided by wavelength is 4L. Then we can get for the short one, frequency F1 should be equals to V divided by 4 times 50 centimeters. 50 centimeters means 0.5 meters. 4 times 0.5, 2. Then V over 2 is the frequency of first tube. Then for the long tube, we can use same relationship. If the frequency F2, we can get F2 is V divided by 4 times. Now tube length of the tube is 50.5 centimeters. It means 0.505 meters. Then we can get V divided by 4 into 5, 20, 0, 2 remaining, 4 into 0, 0 plus 2, 2, 4 into 5, 20. We have to separate 3 decimal places, 2.02. Now they have given beats frequency. Beats frequency is F1 minus F2. We know that difference of frequencies should be equal to beats frequency. When considering difference, we know that high frequency could be observed for the short tube. Then beats frequency 3, we can substitute F1 is V over 2 minus F2 is V over 2.02. Then we can find V value from the equation. I will multiply all terms by 2.02. V over 2 multiplied by 2.02 minus V over 2.02 multiplied by 2.02. Then I will simplify it. 3 into 2, 6. 3 into 0, 0. 3 into 2, 6. 6.06. We can cancel out to 1.01. 1.01 V minus V. It means 0.01 V equals 6.06. We can cancel out 2 decimal places. Then V is 606 meters per second. Then I will find the F1 frequency. Therefore, F1 equals V divided by 2. V is 606 divided by 2. It means 303 Hertz. Then F1 is 303. F2 should be 300 because of difference of frequencies 3 Hertz. Then answer is 1. An organ pipe closed at one end resonates with one of the string of guitar. The length of the string is 0.8 times that of pipe. Of both the pipe and string vibrate at their fundamental frequencies and the incorrection of the pipe is neglected. The ratio of speed of wave on the string divided by speed of sound in air equal to. Now there is a closed tube and a string. For the closed tube, lambda over 4, 1/4 of wavelength equals length. Then we can write lambda over 4 equals L, lambda equals 4L. It is resonating with string. For the fundamental, there is only one loop. One loop means lambda over 2 equals L. I will consider it as L dash. And wavelength lambda dash. Lambda dash divided by 2 equals L dash. Lambda dash equals 2L dash. They have given that the length of the string is 0.8 times pipe. Then this one is 0.8 L. Lambda dash equals 2 times 0.8 L. Now we can use V equals F lambda. For the tube, V equals F lambda. V equals F into lambda is this one, 4L. For the string, velocity I will consider velocity of string is velocity of velocity of wave in string is V dash. Frequency is same as this one because of they have given tube and string are resonating. When resonating two objects, frequency should be same. Wavelength is this one, 1.6 L. Then we can divide second equation and first equation. We have to get the ratio between velocity of wave in string and velocity of sound. Then we can cancel out F and L. 1.6 divided by 4 is 0.4. Then answer is 3. For the 50 centimeters long hollow cylindrical tube. Long hollow cylindrical tube. Open at both ends placed in air. The sound source is produced. PO tone is placed adjacent to the one end of the tube. The frequency of the emitted sound is increased gradually, starting from very low value. At frequency 320, the tube resonates. The speed of sound in air is, we have to use V equals F lambda. There is an open tube. Then lambda over 2 equals L. There is only one loop. One loop means lambda over 2. Half of wavelength. Lambda over 2 equals L. Lambda equals 2L. Now we can use V equals F lambda. They have given that frequency is increasing from a small value. It means we can observe fundamental first. We have to find V value. Frequency is 320, 2 times L value is 50 centimeters, it means 0.5 meters. Then we can simplify it, 320 meters per second, velocity of sound. Then answer is